ES6 classes. So what are classes? In JavaScript, class is basically a blueprint for creating an object. It encapsulates data and functions to manipulate that data. Classes are generally syntactic sugar over the prototypal inheritance pattern. They are basically a special type of function. So let us take some time to look at the prototypal inheritance pattern before we dive into classes. So the way we define a prototypal inheritance pattern is by first defining a constructor function. So we can call the function keyword, then have the function name. And one thing to note about the function name is the first character of the function name is capitalized. That is what makes this function a constructor function. So we can have a property of name and pass in a parameter of name. And on the prototype of the person constructor function, so person.prototype, we can define methods on the prototype. In this case, getName, to keep it simple. And have a function. Then we are able to return, what am I missing? Function. And basically we are able to return the name property or the value in the name property. And the way we call it is by first initializing the person class, for lack of a better name. So call person. We have to new it up, then call the constructor method or function. Then we pass in the name Kelvin. And we can console.log the result. And that is person.getName. And you can see that we are getting the value that was passed into the constructor method and returned by the prototype method. So basically, classes are just wrappers over this. So in order for us to understand the similarity between the class and the prototype pattern, with this in mind, it is easy for us to convert this into a class. And the way to do it is first by getting rid of the function keyword and replacing it with class. And then we can get rid of the brackets. And since it is a class, it will definitely need a constructor function where the assignment to the name property will be. And then the method, instead of defining it on the prototype, you can define it in the class and it will basically return the same functionality. And you can see that we are ending up with the same results. So generally, classes are just syntactic sugar over the prototypal inheritance pattern. So it is good if you have an understanding of the prototypal inheritance pattern, then you know exactly why classes were introduced. For me, this is short code, which we love on this channel, but it is also good to understand the prototypal inheritance pattern because there might be scenarios where you encounter that. So what are some of the differences between classes and the prototypal inheritance pattern? Two that come in mind. I think I'll leave the last one so that you can go and search it out for yourself. The first one is classes are not hoisted. What does that mean? If I define a class, I need to define it, then call it after the definition. So if I try to move this functionality to the top of the class, you can see, hey, the person class cannot be accessed. So this is one of the features of classes. It is not hoisted. You need to define the class. Then after the definition, you are able to call it. Number two, all the code in a class runs in strict mode by default, and there's no way to change that functionality. But when it comes to the prototypal pattern, you have to define if the code within the constructor function will run in strict mode or not. Let us take a look at getters and setters. So what are getters and setters? So on a class, you are able to get access to the get keyword and set keyword. And you're able to do some pretty awesome things with this functionality. So instead of passing the name through the constructor, assigning it to the name property, then accessing it on a get name function, that is a lot of code that you're writing. So generally, we might not need the constructor for this case. And we are able to get, let us just change this to lowercase, get name. And I think for clarity, just to show that they are different, we shall use text instead. So set name, and we can pass in text. So this dot text is equal to text. Then check this out. So after newing up the class or initializing it, we can basically say person.name is equal to Kelvin. We can assign that to Kelvin. Let us call it outside the console. Then call, and that is pretty awesome functionality. And the beauty about setters and getters is we are able now to do some basic validation in the setter method, or if you want to manipulate it, you have the ability to do that in the setter method and the getter method. And you can see that it works pretty much in a very straightforward manner. Another thing that we can take a look at is class expressions. Class expression, what does that mean? An expression could be something as simple as, let's say, const maybe name is equal to Kelvin. So this is a very simple expression. You can see that I am assigning a value to a variable. So with classes, you can be able to assign a class to a variable. How? Because functions in JavaScript are first-class citizens or objects, and one of the properties of first-class function is you are able to assign functions to a variable. And we do know that classes are generally special type of functions. So you can see that I can have a variable rather called name. Then I am able to assign a function to that constant. And that is perfectly okay in JavaScript. The same way, we are able also to assign class to a variable. In this case, I'm using a const. That is perfectly okay. You are able to do that in JavaScript. Let us take a look at static methods and static properties. So let us return this back to how it was. Static method and static properties. What are they? Basically, static methods are bound to the class and not the instance of the class. What does that mean? You are able to access a static method and properties without initializing the class. And the way to define it is we have to use the static keyword. So we can say static, maybe count is equal to 0. And the way to access count is by calling the property directly on the class. So we don't need to new up the class. We can simply, let me get rid of this code to create more space. So we can basically call in the class, then call the count property directly. And you can see we have access to the static property without newing up the class or initializing the class. Similarly, with the static method, maybe static, let's just call it get count. Maybe we just return hello for now. So without newing up or initializing the class, we have access to the static method, and you can see we get hello. Something funny happens. So let us try to have access to the count property. So this dot count. This works, but the best way to do it is by calling the class instead of calling this, because it's a static property. So the best way to call it is by calling the class name on a static property instead of calling this. But obviously you can get away with this, but in some instance it might fail. So just be wary about that. In case it fails, just know that you need to call the class name, then the static property. One thing about classes is classes can have computed property and names. And a good example for us to take a look at this is maybe using symbols. So I can easily define a symbol called first name. And if you don't know what symbols are, I have created a video about symbols. I'll be linking it up in the card above. Then call it a symbol. And basically a symbol creates a unique value every time you call the symbol function. Another thing is the argument that I'm passing in the symbol is just for description purposes. It has nothing to do with the value. Then I am able to define a function. Let us make it static. And that is perfectly okay syntax. You are able to use computed properties as function name, as property names. And the way to call it is by basically calling in the computed property, in this case, first name. The final thing that we shall look at is inheritance. So we are able to inherit properties from one class into another. I know it was a pain when dealing with prototypal inheritance, but classes have really made inheritance simple. So I can easily define another class, or rather, let us have a person class and have another class called uncle. And the uncle class extends the person class. So generally, by doing this, all the functionality that exists in the function class now exists in the uncle class. So by simply just replacing the person with uncle, you can see that we have access to all the methods that have been defined in the person class directly in the uncle's object. And we are also able to add more functionality. Maybe just one thing to note and take advantage of is if the parent class has a constructor method, which accepts properties. In this case, let us just call it name for lack of a better name, no pun intended. And this dot name is equal to name. The way to make sure that this works is you have to call super. So calling in the constructor, then properties that are passed in, you have to use the super keyword, then pass in the props. And this makes sure that the values that are being passed into the uncle class are passed into the parent constructor class. Let us new up the uncle class so that we have access to the name property. So const uncle, new uncle, and pass in the value of Bob. And you can see that by doing that, we can now have access to uncle.name, which is Bob. And you can see that we have access to Bob. And we have access to Bob. So this is best practice. And I know as JavaScript evolves, you can be able to access the name property without even calling the super function in the child's class. It will also work, but for best practices, consider doing this. If you have enjoyed this video, don't forget to like, subscribe, and share this video. Thank you and see you in the next one.